Let's change some repeating decimals into fractions. Yesterday we did see that there's a super shortcut for taking something like 0.2 repeating and turning it into a fraction. If I have one digit that's repeating, I'm going to take that digit, put it in the numerator. And my denominator is going to be 9. That's it. If we will have more than one digit, like 0.21 repeating, I'll still take that 21, put it in the numerator, but since there's two digits, I'm going to use 99. Then we should go through and simplify this as well. I can divide both numerator and denominator by 3, so that's 7 over 33. There's lots of repeating decimals where it isn't every decimal to the right of the decimal point that's being repeated. In this case, 0.032. Only the 32 is being repeated. So I'm going to think of this decimal as being k. And I want to write this equation that only has the repeating part to the right of the decimal. That meant I had to move the decimal point from before the 0 to after the 0. To do that, we multiply k by 10. Now I want to create another equation that shifts that decimal all the way over to after the first set of repeating. So we have 32.32 repeating. That means I got to move it in another 2 spots, 3 in total. So I had to multiply k by 1,000. Now I've just created this system that I can solve by subtracting. 1,000k minus 10k is 990 k's. And when I subtract on the right-hand side, then these repeating parts cancel each other out. And I'm just left with 32. That means to solve the equation, k is going to be 32 over 990. We'll finish this up by simplifying the fraction. Both of them are even, so I'll divide by 2 and get 16 over 445. And there's our fraction. So let's do that again with something like 0.32, where only the 2 is repeating. Again, I'm going to think of this as my value k, and I want to move the decimal to after the 3 so that I get just the 2 is repeating. That meant that I had to multiply k by 10. And I want to create another equation where I move the decimal to after that first set of repeating, so 32 times 0.2 repeating. That meant that I had to multiply k by 100. When I subtract off this entire equation, 100k minus 10k is 90k. And on the right-hand side, when I do 32.2 repeating minus 3.2 repeating, the 0.2 repeatings cancel each other out. And 32 minus 3 is 29. We can finish it off just by dividing. 29 divided by 90. 29 is prime, so that is going to be our fraction.